Hi everyone. Welcome back to my next session. In the last session, we discussed about what is multibiometrics, why multibiometrics is more accurate than the unimodel. And then we discussed about the different types of the biometrics, I mean multibiometrics. And then finally, we discussed about what is prior to matching. Okay, in prior to matching, the most important problem will be the PCA problem that we are going to discuss right now. Now I'll be sharing my screen. So I already solved the problem. I'll be sharing that right. So this is a question, we can take it out. So given the following data, use PCA to reduce the dimension from 2 to 1. Because if I'm having the multiple features, I mean multiple rows, it will be very difficult to operate the data while we are passing any kind of the things that we are implementing on it. Okay, so what you have to do is that, so X and Y, and the example was given in this problem. So X, Y and X feature represent the rows, and example 1, 2, 3, 4 represent the column. So there are 4 samples are there. So in the step 1 data set, so I'm having the multiple rows. So multiple rows means n equal to 2. And number of samples means n equal to 4. Okay, now we can move into the next step. So first step, we discussed about what is available in the given question, and it contains the data set, and it contains the multiple features and 4 samples. The features is equal to represents the rows, and sample is equal to columns. Okay, now I have to find it out the mean. Mean is a very simple thing. You can look into this question. So this is a X. For this, I have to find a mean. So 4 plus 8 plus 13 plus 7 divided by 4. If I simplify this, I'll be getting 8. Next feature I have to go. So 11 plus 4 plus 5 plus 14. If I add this row, you will be getting 8.5. So now I found it out the mean variable. Okay, now what I have to do is that I have to move into the covariance matrix. So before finding the covariance matrix, we have to know the ordered pairs. So what is an ordered pair? X comma X, X comma Y, Y comma X, and Y comma Y. So these are the ordered pairs. The thing is that how to find the ordered pair, I will say. So for first, I will be saying for X comma X. So if you move into the X comma X, so 1 divided by n minus 1. N represent the features, how many columns that you are having. 4 minus 1. And you have to find it out, just check out the first row. So 4 minus the mean value, 8 whole square. And then plus, you have to move back to the question. So 8 minus 8 whole square plus 13 minus 8 whole square and 7 minus 8 whole square. Okay, this is for the covariance X comma X. I'll be repeating again, 1 divided by n minus 1. N represent the number of the samples. And then 4 minus 8. 4 minus 8 whole square plus 8 minus 8 whole square plus 13 minus 8 whole square, 7 minus 8 whole square. This is for X comma X. This is what I represented here. So 4 minus 8 whole square, 8 minus 8 whole square plus 13 minus 8 whole square plus 7 minus 8 whole square. And next we have to move into the covariance of X comma Y. If it is X comma Y means 4 minus 8 into 11 minus 8.5 plus 8 minus 8 into 4 minus 8.5. So that's what it was written here. So 4 minus 8 into 11 minus 8.5. 8 minus 8 into 4 minus 8.5. Now we can move into the example 3 out here. So 13 minus 8. 13 minus 8 into 5 minus 8.5. Finally, 7 minus 8 into 14 minus 8.5. Okay, this is what it was represented here. Finally, the value I'll be getting will be minus 11. Okay, and similarly, y comma x means it is a reverse of it, we'll be getting the same value. And finally, covariant y comma y. How I did x comma x, in the similar way, I have to do y comma y equal to 1 minus n minus 1. N represent the number of the samples. So 4 minus 1. Okay, and go back to the previous step. So 11 minus 8.5 whole square, 4 minus 8.5 whole square, 5 minus 8.5 whole square, 14 minus 8.5 whole square. So finally, we will be getting the answer for covariant y comma y. So, this is the value of the covariance matrix. Now I have to find it out what is the covariance, because without the ordered pairs we cannot find it out the covariance matrix. So this is the reason why I am taking an ordered pairs. So after that, S equal to covariant of x comma x, x comma y, y comma x, and y comma y. This is represented as 2 cross 2 matrix. And what is the value of x comma x, x comma y comma y, and y comma, so y comma x and y comma y. I just substituted as it is. Now I have to find the eigenvalue, eigenvector, and normalize the eigenvector. The formula is determinant of S minus lambda I equal to 0. So the determinant is, so what is the S value? S represents the covariant matrix. So 14 minus lambda into I means identity matrix. So lambda 0, 0, lambda. If I substitute that, I will be getting this value. So then 14 minus lambda into 23 minus lambda minus 11 into 11 will be 121. So if I simplify this, I'll be getting this value. Lambda square minus 37 lambda plus 201 equal to 0. Okay. And if I apply the quadratic equation, so this is the formula I have to apply it. Okay. So minus b, this is the formula. I cannot able to highlight. I'll be just dictating the formula minus b plus or minus root of b square minus 4ac divided by 2a. If I substitute this, so A will be 1, B will be 37, and C will be 201. If I substitute these values in this equation, you will be getting the value for lambda 1 and lambda 2. And in this, what I have to do is that I have to take out the bigger value. And again, vector, I have to take it. And which is the bigger value? Lambda 1. So I have to change the slight variation in this. So S minus lambda 1 I equal I into I have to apply U1 and U2. The reason is that I'm applying the 2 cross 2 matrix. So I have to apply U1 and U2 equal to 0. So same thing. The lambda 1 is greater. So 14 minus lambda 1 into U1 minus lambda U2. And minus 11 U1, 23 minus lambda 1 U2. Okay, this is the first equation and this is the second equation. So if I simplify the first equation, so 14 minus lambda 1 U1 equal to 11 U2. It will be coming. I skip this step. Okay, 11 U2. So U2, that 11 will be in the multiplication. If I take here, it will be coming here. If I simplify this, U1 will be equal to 11 and U2 equal to 14 minus lambda 1. Okay, I have to substitute this as it is. 11, 14 minus lambda 1. What is the value for lambda 1? 30. Okay, I have to apply that. So 11 minus 11 divided by minus 16.3. This is what I get here. So I have to simplify this finally now. So while I am simplifying it, 11 divided by root of 11 square plus in the bracket minus 16.38 whole square. In the next step, minus 16.38 divided by root of 11 square plus of minus 16.38. Okay, if you simplify this, you will be getting the answer like this. So in the last step, what you have to do is that if I take a lambda 2, this will be the value, but I already said that the greater value I have to take it. So lambda 1 is preferred. Now what I have to do is that I have to convert that data set into the single data set. The formula will be E1 of t. What value I got already for E1? So E1 I got 0.55 and minus 0.83. So I have to find the transpose of it and I have to take out each example and I have to minus it. So first initially the first value for x bar, sorry, for x is 4. So 4 minus 8 I have to put and then 11 is for y. So 11 minus 8.5. You have to simplify that. So I'll be going back to the first step. Listen carefully. So this is what I said. 4 minus 8, 11 minus 8.5. And in the next step, you have to put 8 minus 8, 4 minus 8.5. In the next step, 13 minus 8, 5 minus 8.5. 7 minus 8 and 14 minus 8.5. So that's what you have to apply in this. So 4 minus 8, 11 minus 8.5. This is for the first column. And then next one, you have to apply 8 minus 8 and 4 minus 8.5. I'll be going back to the previous step. So 8 minus 8 minus 8, 4 minus 8.5. That's what I written here. Okay. And this will be the answer you'll be getting. Similarly, you have to do for the third step as well as the fourth step. Okay. Finally, you have to apply all these answers in the single row. Okay. So this will be the solution for this. Now I converted the multiple data sets into the single data set. So initially, what I have to do is that first step, I have to take a data set and I have to find how many features are there and how many samples. The feature is represented as a row and sample is represented as a column. Then I have to find the mean value and then I have to take the ordered pairs, and through that what I have to do is that I have to find it out the covariance matrix. And then I have to find it out the agent value, agent vector, and normalize the vector. After normalizing it, finally, I'll be converting the multiple data set into the single data set. Okay. In the next lecture, we can discuss about after matching what we are going to do, as well as we'll be discussing the another important problem in the multi-biometrics will be LDA that we will be discussing. Okay. Now I'll be stop sharing it. Thank you.